Good morning.
Good morning, sir.
Good morning.
Shall we start?
Yes, sir.
Or we need to wait for 1 or 2 minutes? Here we have only 40 participants. Start பண்ணுவோமா அல்லது ஒரு நிமிஷம் வெயிட் பண்ணுவோமா?
10 நிமிஷம் வெயிட் பண்ணுவோம் சார்.
ஓகே. We could continue with our lectures. We will see the first the calculations. Can you all see the screen?
Yes, sir.
Can you all see the screen? Somebody has to say yes or no, sir. Yes or no? Yes, because I don't know, because from this end I cannot see whether you are viewable for the screen. Right. Now, some people have said they have done the homework. Then I will ask from starting from then, right? So now we want to construct the ANOVA, right? As you all know, you know already how to put up the model for this situation. This is a split plot situation. So we have here two information. One is called the water levels, right? So this is under the irrigation. This is under the rainfall. Then we have nitrogen. We have nitrogen 3 level, 0, 15 kilogram per hectare, and the 30 kilogram per hectare. So these are the 3 levels of nitrogen factor. So that we basically have 2 factors: irrigation and the nitrogen. And here we could see which is in the main factor, which is in the which is in the main plot and which is in the subplot. Anyone? Can you guess which is in the main plot, which is in the subplot?
Irrigation in main plot.
This is in main plot, right? This is in subplot. So you can imagine we have basically 2 irrigation, and the rainfall, for example. Then we have 3 levels of nitrogen, 0 level nitrogen, right? Nitrogen with 15 kilogram, nitrogen with 30 kilogram. This is before randomization. So 0, then 15, this is 30. So how many replicates are there? Or how many blocks are there? From your data, how many blocks are there?
3 blocks.
3 blocks, yes. So likewise, this is block 1, this is block 2, this is block 3. So that is the information given there, right? So basically, this is the real picture of the experimental setup. So this is called as this experimental setup is called as field layout, right? This is the field layout. We will have to give the field layout after randomization. Yesterday we have seen a field layout, right? I will post some of the notes from the factorial, from the what do you call nested design and the split plot design. Unnecessary thing I will erase it and edit it and put it on the LMS, right? So I will upload all these things together, right? Right. So this is the basic setup, which we call it as the field layout. Now we will come to the Anova table, right? Anova table. So all of you know the Anova table. The first step is source of variance. I will write it in a very short in form, source of variance, degrees of freedom. First, we will fill out all these, then we will go for the next. Right, now, Shalomi, huh? Shalomi, tell me, what are the source of variance coming here in this?
Block.
Good, block. What else? Pardon? I couldn't hear.
Factory.
Oh, I didn't hear. Maybe something wrong with your mic. What is that?
A.
Yeah, here we don't call A, B, C, no. Now you'll have to tell in real terms. This is in practical.
A, sir.
Oh, A and
Factory.
the what is A here? What is A?
Irrigation.
Irrigation. Here we cannot write as A because we are coming as a real practical. So we say irrigation. So A, B, C business go on with the example. If you take a factor as with the name A, then we call it as under the source of variance, it is A. Now it is irrigation because you cannot say A now. Right, Shalomita, good. What is next?
Error irrigation.
Error irrigation.
Error.
No, we call it as error, not for irrigation. Error irrigation. So we can say it is the first error type. We can say error A because it is a different type of A. We cannot say error irrigation. Why? Why? Can you look at yesterday I mentioned what is this error? In previous example, look at it. What is this error? Error is the product of what?
Interaction between the block and the irrigation.
Therefore, we cannot say error irrigation. We cannot say error irrigation. Why? Because in calculation, this is the interaction between block and irrigation. So therefore, this is the interaction between block and irrigation. The error is the interaction between block and irrigation. So that we cannot say it is error irrigation, right? So you can say error A. It's a one type of error. Error A or first error or indicating there are two types of error. Good. Maybe Arosha, good. What is next, Arosha?
Nitrogen.
Nitrogen. I will put it in black color. Nitrogen. Right. So this is one component, this is another component, this is another component. Nitrogen. Right. Continue, Arosha.
Interaction of irrigation and fertilizer.
Interaction between
Irrigation and nitrogen fertilizer.
Nitrogen. Interaction between irrigation and nitrogen. Right. So that is another component.
Error B.
Okay. Error B.
and total.
And total. Good. Very good. So this is the setup. So many things need to be calculated. Block irrigation, error A, nitrogen, irrigation into nitrogen, then total, and block B. Sorry, error B. Right. I will catch up another person. Madhusha, Pushparaja. Tell me what is the degrees of freedom? We need in numbers, huh? Bus la irukkriyalo, bus எல்லாம் horn அடிக்குது. Yes. Yes.
For block.
Pardon?
R minus 1 for block.
Here we'll have to give in numbers. R minus block, yes, R minus 1 is the block degrees of freedom. I need in numbers. What is the degrees of freedom for block?
3.
Huh?
3 minus 1.
C minus 1?
3 minus 1.
Yeah, whatever the formula, I need the, Madhusha, I need the number. நீங்கள் சொல்றது ஃபார்முலால சொல்றீங்க C minus 1, D minus 1, R minus 1. எனக்கு தேவை இலக்கம். இலக்கத்தில் எவ்வளவு?
Block 2, sir, block.
Yeah, there are 3 blocks altogether. So that 3 minus 1, which is 2. So I need the numbers, right? I don't need formula, right? I don't need formula. Even in the exam, don't forget, even in the exam, I have seen some of you are giving the template of the Anova table. That is not needed. If I ask, give the template of the Anova table, then you can give. People are writing, for example, this Anova table. People, after giving a particular sum, people are writing the answer like this is R minus 1, for example. R minus 1, this is A minus 1. I don't want this. Because I have given an example now. I know these formulas. You don't need to specify the formula to me. And also sometimes people are writing sums of square. This is summation yi dot square divided by AB minus C. I don't want this formulas. I don't want the answer. I want the answers. When you give a problem, we have already given the problem. So this is the problem that I have given with the numbers. I have given the numbers for all these cells or the values. Now we'll have to replace all these formulas with the numbers. We'll have to replace all these with numbers. You cannot simply avoid that, right? Right, because I have seen in the exam, people are writing these formulas. I don't want formulas. Formulas just to, maybe if I ask, for example, give the Anova without giving any numbers or the values to calculate. If I say, give the Anova for split plot design, give the Anova for split plot design, then we will have to give the Anova table saying A, B, considering factor A, considering factor B, considering factor C. Then you write, then you have blocks so that you can write it as block source of variance, factor A source of variance, factor B source of variance, error A source of variance, factor B source of variance, C source of variance, interactions, etc. etc. Then you give the degrees of freedom in those assumed number of levels. R minus 1, A minus 1, B minus 1, C minus 1, and so on. Right? Now I have given a sum, right? You'll have to tell everything in number. In Tamil, நான் உங்களுக்கு கணக்கு தந்திருக்கிறேன். இப்ப கணக்கின் படி நீங்கள் இதுக்கு வர வேண்டிய இலக்கங்களை குறிப்பிடவும். ஃபார்முலாவில வேலை இல்லை இங்க இதுல இந்த நிலை ஃபார்முலா எதிர்பார்க்கவும் இல்லை. சில பிள்ளைகள் ஃபார்முலாவை தான் எழுதி தள்ளுங்க, கடைசியா கணக்குல ஓட்ட விட்டுருங்க. இதுல கணக்கை தந்துட்டு அனோவா கேட்டால் நீங்கள் கணக்குன்ற இலக்கங்களை மாத்திரம் தரணும் முடியும், கால்குலேட் பண்ண இலக்கங்களை மாத்திரம் தரணும் முடியும் வரும். දැන් මෙතන අපි ප්‍රශ්නයක් කාලා තියෙනවා ඉලක්කම් වලින්. ස්ප්ලිට් ප්ලොට් හරි ස්ප්ලිට් ප්ලොට් හරි ඉලක්කම් වලින් ආලා තියෙනවා. ඉලක්කම් වලින් ආලා තිබුණ නිසා අපිට ඉලක්කම් වලින් ඒ ප්‍රශ්නෙට අදාළ උත්තරේ දෙන්න ඕන. එච්චරයි දෙන්න ඕන. මම බලලා තියෙනවා විභාගේ සමහරුන් මේ අනෝවා එකක් දෙන්න කිව්ව ගමන් ඔක්කොම ෆෝමියුලාස් ටික ලියනවා. ෆෝමියුලාස් ටික ලියුවට පස්සේ ළමයි අත්තම ඒකෙන් ලොකු කාලයක් නාස්ති කළා. ඊට පස්සේ කැල්කියුලේෂන් වලින් ඒගොල්ලෝ ගොඩක් වැරදි වෙනවා. අපි මෙතනින් මං මෙතනින් බලාපොරොත්තු වෙන්නේ ඔයගොල්ලෝ ෆෝමියුලා එකක් දීලා පටන් ගන්න. ඔයගොල්ලෝ මෙතනින් දෙන්න ඕනේ ඉලක්කම් වලින්. Is it clear to everyone? Because I have seen in the past, for last 2 years, I was correcting your papers at the University of Jaffna. Problem is people are using the template of the ANOVA. I don't want, in this case, I don't want template of ANOVA. If you can remember the template of ANOVA, that is fine. Because that is how you can write down the degrees of freedom. For example, degrees of freedom in the template of the ANOVA says R minus 1. What is R here? R is number of blocks. So number of blocks here is 3. So 3 minus 1, 2. The answer is 2. So likewise, this is what I needed. Is it understood by everybody? Right. So I don't give the marks for the template of the ANOVA. I give the marks for this particular ANOVA table, right? Nothing else. I don't care about that. But if I ask as a theory question, give the ANOVA table without giving the numbers, then you'll have to write down all those notations, summation, degrees of freedoms, sums of square, mean square, and so on. Right. I don't want to go further. Right. Madhusha, tell me what is the degrees of freedom for irrigation?
1, sir.
1. There are 2 levels of irrigation. Good. 1. Good. I will catch up another one, another person. So tell me what is the error degrees of freedom? Jayati sir. 1109. You can use the, you can think about your formula. What is your formula? Put it in the formula and get the answer. Yeah. Anyone?
2.
Huh?
2,
2?
sir.
2, yes. How this 2 comes? කොහොමද ආවේ? எப்படி வந்தது?
R minus 1 into A minus 1.
Okay, R minus 1 into A minus. So now you will have to remember the real ANOVA. That is the purpose of giving the real ANOVA. R minus 1 into A minus 1. Right? So now R is 3, A is 2. So that you have to the value. You are getting the value 2. Right. Anyone? What is the degrees of freedom of nitrogen?
2.
2, because it has 3 levels. So that 3 minus 1 is 2. So irrigation into nitrogen?
2.
2. What is total degrees of freedom?
17.
17.
So that means 18 minus 1. So ABR minus 1. Right. What is the error degrees of freedom? You can
8.
say 17 minus the rest. That is also possible. Otherwise, you can use the formula. What is the error degrees of freedom?
8.
8. Right. Right. So this is how your ANOVA should be. Now we will come to the sum source square. Most important. Tell me the block sum source square, anyone? What is the value? Approximate value.
877.82.
Right. Okay. What is the irrigation sum source square?
239.8074.
80.
4.
Right. I will say 80. I will say 80. Right. What is the error sum source square? Error A sum source square.
42.904.
Okay. I will 904. Right. 5. Okay. Right. I will go for 2 decimals. Huh? I don't want 4, 5 decimals. Even though in exams, if you have 4, 5 decimal, you can go for 2 or 3 decimal is enough. Right. What is nitrogen sum source square?
99.567.
5, 6.
7.
Right. Okay. Then what about the interaction between irrigation and nitrogen?
65.61.
Right. Actually, did you all calculate this value or just?
Calculate.
Okay, right. That is more important, right? Okay. Because I have taken from a textbooks that is, you may also familiar this textbook because, right. What is next? What is the total sum source square?
1,331.
Oh, I'm getting a different value.
Total no error, sir.
Total. I'm getting a different value. Cross check with others.
1,331.23.
Oh, I'm getting a different value now. This is from SAS. Anyone getting a different value? Hmm? I'm getting a value because I'm looking at the book. I didn't try. I'm getting a value. We can check this in our practical either tomorrow, today or today. We cannot. Probably tomorrow. 549.89. I'm getting a value something like this. Are you all getting this value or different value? Anyone? Tanish Kumar?
Yes, sir.
என்ன உங்களுக்கு வேல்யூ
Sir, நான் செய்யல.
ஏன் பக்கத்து வீட்டுக்காரர் யாரும் செய்வீங்கன்னு பார்த்தோன்னு Vidurshan?
Sir,
Yeah, what is the answer?
my answer also 1,300.
Oh, what did you do? How did you get? Because this is a compute output from a book. Maybe wrong, I don't know. Maybe wrong, I'm not sure. Because I didn't do this. So that I'm not sure whether these values are correct. For the time being, we will have it like this. We will do it this same example in SAS. Remind me, we will do it in SAS so that we can cross-check the values. Is that okay? It takes more time for us now to do it. Because it is simple, because summation Yij k square minus correction factor. This is the total sum source square. So that is, for example, in our example, 26.8 square plus 29.2 square and so on, so on. The last value is 8.4 square minus the correction factor. What is the total? Grand total. I couldn't remember. That is the grand total. Y dot square divided by A, B, R. If you have done, I'm not sure how it is. So what is the value that you are getting? 1,000?
1331.229.
1,300, right? Yeah. So we will have to cross check the values. But I'm also not sure. Can you all calculate once again and see? How many says this is correct? Almost all, right? For me, it is a different answer because it says it is from the book which has been run through the SAS. So normally, maybe typo error may be there, but right, we will consider without wasting time. We will consider this my value as the correct value. It doesn't matter, right? We will do it later, right? So this is my sums of square. So what is the error sums of square? Total minus the rest. What is the error sums of square? Can you calculate and tell me what is the error sums of square? That is total minus rest. Total is 549 minus rest. Anyone? Error B. Jayati sir. 1109 Jayati sir. Jayati sir not there. One 1109 Jayati sir not there. Hmm. 1109 Jayati sir. Class එක නැද්ද? ඉන්නවද? මට නම් ඇහෙන්නේ නැහැ. You can put the answers in chat box. You can respond in the chat box. Chat box works. Only problem is the mic. Right. Anyone, what is the error component, error B component of the sums of square? Very quick. We are wasting time.
So if we get this one, minus will come.
If we get,
500.
right. Yes. What you all said is correct. Right. Then we will, normally sums of square cannot be minus. Right? Yeah. Tell me the value. 1,300 and
31.23.
31.23. Okay, fine. So we will have it stop with this 2 decimal. Now what is the error term?
5.52.
5.52.
52.
5.52. Okay. Good. Right. We will keep this as the correct answer. We will continue. Right. Now we can calculate the mean squares. We calculate the mean squares for block mean square is not necessary. We calculate the mean square for irrigation. We calculate the mean square for error A. We calculate the mean square for nitrogen, we calculate the mean square for interaction between irrigation and nitrogen. We calculate the mean square for error B. Can you calculate the mean squares and tell me what are the values? Block mean square is not necessary. If you want, you can calculate, but not necessary. Give me the mean square for irrigation, error A,
39.8.
39.8.
239.
239.8. Okay. What about error A?
21.45.
What about nitrogen mean square?
49.78.
What is the interaction mean square?
32.80.
The last one, error B mean square?
0.69.
Right. So these are the mean square that you need to calculate. The reason is these are the mean square that we are going to consider for our further explanation. We don't want the mean square of block, mean square of total. If you want, you can calculate, but not necessary. The marks will be given only for this, because these are the mean square needed. Sums of square, you'll have to calculate all the sums of square. Degrees of freedom, all. But mean square, not necessary for others. But you can calculate if you want the mean square of this. Fine, no problem. But my allocation of marks is only for this, because this is the important mean squares that comes for the calculation later on. Right, we can calculate the values. What are the values? Tell me, what is the F calculated value for this nitrogen? This is interaction. Tell me, what are the F calculated value for each of these cases, according to our knowledge now?
Irrigation.
Yeah. What is the value?
11.17.
Irrigation
178.
11.17.
17.
Why did you get 11.17? Can you explain?
Mean square of A divided by mean square of error A.
That is good. So this is actually mean square of A divided by mean square of error A. Right? So that is why you are getting that value. Right. What about the next one? Nitrogen and the, what do you call, interaction between nitrogen and irrigation. The F calculated value? F calculated value. Yeah. For nitrogen?
72.149.
Okay. 72.14. Fine. What about the interaction?
47.54.
Right. Good. Good. So these are the mean squares. Sorry, calculated value we need. Now we can do the testing. Remember this value. Remember this value, because I'm going to go down. Remember these values. These three values of calculated value. Right. Now I can test one by one. First, I'm going to test irrigation. Irrigation effect. Here we need to test all the effects. Here we need to test all the effects. Interaction and all the effects. First, I am going to test irrigation effect. So my null hypothesis, if you consider irrigation as, let's say, I as block, J as the irrigation, and K as the nitrogen, right? So how we can formulate our null hypothesis? Null is alpha. You can write down the model. I might ask to write down the model. So you know the model, right, of split plot design. Alpha j is equal 0. So assuming I is the block. So this is my null. Alternative is at least one alpha I is different from the rest. Right. Now that is my null hypothesis. My calculated value, we set 11 point something. What is that?
17.
Now, what is the table value? Look at the table value for this. Anyone? What is the table value? At alpha, we consider alpha 0.04. Very quickly, we are wasting time. Yeah, we can go for the next topic.
18.5. 18.5.
18.5. I'll have to cross check. Yeah, what is the numerator degrees of freedom? What is the denominator degrees of freedom? Yeah, maybe you are right. Numerator degrees of freedom is 1. Denominator degrees of freedom is 2. So that this is the value, 18.51. You are right. So that here it is 18. What is the answer? What is the value? 18.15.
18.51.
5, right. Right. Now, what can you say about this, comparing these two values? This is my critical value. This is my rejecting region. This is non-rejecting region. Tell me, what is the scenario here? Are we rejecting or accepting?
Accept null hypothesis. Reject alternate.
Huh?
Accept null hypothesis.
Okay. Do not, because our calculated value is less than the table value. Therefore, do not reject our null hypothesis. So, in another term, accept our null hypothesis. So, another term, we could say, what is my conclusion? There is no anyone? Irrigation effect. Or another term, if you want to further write it nicely, what are the irrigation types were there? What are those two?
Rain-fed and irrigated.
Rain-fed and irrigation. So we could say there is no yield difference between irrigation, there's irrigated field and rain-fed field. There's no yield difference. Or in other term, we can add one more term here. There's no significant yield difference between the irrigated field and the rain-fed. Okay. So likewise, we can test the rest. We can test for nitrogen. What is the calculated value? Nitrogen? 72 point something, right?
1, 2.
Okay. So what is the table value in nitrogen? So nitrogen, we can say our null hypothesis is beta k is equal to 0. We can test that. What is the table value? Look at the table value. What is the table value?
4.46.
4.46.
46.
So definitely this is much lower than this. So we could say reject H0. We reject H0 because calculated value is much higher. So that what is the conclusion? What is the conclusion? Definitely there is
Effect of nitrogen.
there is a significant difference of what? There is a significant difference between the levels of nitrogen. Nitrogen on yield of paddy, because we are talking about paddy yield, right? I think so. We are talking about paddy yield, yes. There is a significant difference between the levels of nitrogen on yield of paddy. So that we can see. Right. Similarly, go back to the third one, the interaction between irrigation and nitrogen. So we say alpha beta, that is my null hypothesis, alpha beta jk is equal 0. Alternative is not equal 0. My calculated value is, I'm getting the value. What is the value? 47 point something, 52 or something. Right. Now, what is my table value? Table value, everybody should know now how to look at the table. So table value is depend on alpha value and the degrees of freedom of numerator and the denominator. So can you comment on? What is the value? Table value. Anyone?
4.46.
4.46. Everybody should know how to look at the table value, right? Right. So definitely, once again, this is highly significant. Why? Because the calculated value is higher than the table value, much higher than the table value. Therefore, we reject our null hypothesis and the accept alternative hypothesis. What is my conclusion? What is my conclusion? There is a significant interaction effect between irrigation and nitrogen. Irrigation and nitrogen. There's a significant interaction effect between irrigation and nitrogen. As I pointed out, if you find significance in all these Anova tables, what is the next step that we need to follow on? I mentioned this. If you find the significance, what is the next step you need to follow? If the Anova is significant, when I say Anova, depend on what component that we are testing. If ANOVA is significant, what is next? We need to go
Mean
for
separation.
mean separation. Have you all done a little on theory on mean separation? Karada? Sayingla? இல்லையா?
No, sir. Say it.
என்ன பிரச்சனைண்டா எனக்கு நான் tomorrow I might talk about mean separation, or today I can talk about mean separation with the ANOVA. Only problem is if you don't understand the theory, how I am going to explain. That is a problem. என்ன செய்யறாண்டா எனக்கு போறாங்க. Right, we will sort it out later. Right, any questions? Any questions and any doubts on the other homework? I gave 2 homeworks now. Any doubt in the homework? You can ask the doubt in the homework. Huh? Any doubt? You can put forward any questions. Any doubt in the homework? The other homework I asked to write down the Anova table for the split plot design. So any questions or any doubt, any clarification on that? Or are you all perfect? Somebody try to speak, but I don't hear. ஏதாவது பிரச்சனை இருந்தா கேட்கணும். முன்னாடி பிரச்சனை තිබුණොත් අහන්න ඕනේ. මං අල්ලලා කන්නේ කවුත්. So you'll have to ask the question. If I ask in other forum, you should be able to explain. Quick, I'll have to move to the other section. Tanush Kumar, ummada tharlayatan urutonu merenda nedan backstep. And metacal kuputalum answer pannine. Backstep bound to answer, no? That is called backstep. Yes. Tanush Kumar.
Yes, sir.
Huh?
Sir, I will answer correct one to solve.
விளங்கல. நீங்க சொல்றது விளங்கல எனக்கு. ஆன்சர்
அவையல் செய்து வச்ச ஆன்சரை கரெக்ட் ஒன்று சொல்ல சொல்லி கேட்கு.
கரெக்ட் விளங்கல எனக்கு. அவையல் செய்த ஆன்சரை கரெக்ட் ஒன்று பார்க்கட்டாமோ?
ஆம் சார்.
யாரும் எனக்கு ஷேர் பண்ணக்கூடியதா இருக்குமா? ஸ்கிரீன் ஷேர். அப்பதான் கேட்டு பாருங்க, ஷேர் பண்ண ஸ்கிரீன். நான் ஷேரிங் authority தரேன், ஷேர் பண்ணா நான் டிஸ்கஸ் பண்ணேன்.
That who did the share that screen, sir will check.
If you all can share the screen, any format, Word or any format, PDF or whatever the format, I can discuss.
Sir, split plot not did, sir.
Huh?
So that one not did, sir.
You didn't do. No, I'm asking anyone who, because I'll have to write down all the components. So if somebody come up with the components, I can say this is correct, this is wrong, this is how to write, and so on. Right? Okay, so next time if you come up with, tomorrow also we have class, so that if you all come up with, I can give my suggestion. Right. Then we will move to the other section. Okay. Let's see what are the chats. Yes. Today I'm going to start. Okay, next time you come up with what do you call the idea for this split plot design, then we will discuss about that. Right? Is that okay, Tanush Kumar?
Yes, sir.
Yeah, நீங்கள் செய்து கொண்டு வந்தால் தான் நான் அது சரியோ பிள்ளையோன்னு பார்க்கலாம். நீங்கள் செய்யாம விட்டால் நீங்கள் முயற்சியை செய்யாட்டி அது பிள்ளைதான். So I gave you some idea how you can write down the common ANOVA for split plot design. Now we'll have to write for split plot design. At least some degrees of freedom, some sums of square. You come up with the idea. Write down the model first. First we'll have to write down the model. Then only we can follow the what do you call ANOVA. Somebody has already did, but cannot share. And share one you can make it into PDF and you can share it now. Can you PDF and share one if you have in the lab? Can you PDF and share one? So we will do it tomorrow. If you get ready somebody to share it, then we can do it, right? So we will do it in that way.
Okay.
Right. Today, this is also one of the very important design. This is actually, it's a combination of design, right? Called as analysis of. Earlier we learn about, right? In earlier case, throughout earlier case, we learn about analysis of what? So we learn up to now the term called as analysis of variance. It's called as ANOVA. Now we have put up a title called as analysis of covariance. It's called as ANOVA. Some people are writing ANCOVA. Same thing, huh? Sometimes if you see ANCOVA or ANOCOVA, all are same. ANOVA. ANOVA means analysis of covariance. So this part, COVA, is actually referring the covariance, analysis of covariance. Actually, what is covariance? Just to introduce some term in covariance. Covariance. Covariance means, let's say variance. What is this? Variance. I have a variable x, some values. This is the random x variable. Let's say if I calculate the variance of this, it's called as variance of x. Let's say if I have another variable y, I calculate the variance of y, it is called as variance of y. Right? So if I calculate the variance of x separately, variance of y separately, it is called as respectively variance x, variance y. Now what I am going to do is, I am going to calculate the variance of these two. For example, multiplying this x and y. So I have another column, x variable and y variable. After multiplying x, y, you have here the information. So this is called as, now it is not only one variable in calculation of variance. How many variables are involved? Two variables. So this is called as covariance of x, y. Is it clear? Do you know the difference between variance and covariance? So variance means we are dealing with only one variable at a time. Covariance means combining the variable. Here we are going to look at only two variables covariance. There may be covariance, for example, x, y, z, much more complicated. Or any covariance. Covariance could be any systems. Right. So that is the basic principle of this meaning of covariance. Right? Yes. I will switch to the other section, this direction also. For example, you have already learned from Madam. Can you remember this design? What is that design?
Randomized complete blocks.
Right, randomized complete block design. What is the aspect of here compared to other previous design?
Here, other than the treatment, another variability also, another known variability also there.
Good. How do you call and why we want to have that?
Because that is due to the border, that is due to the block effect.
Okay, that is due to block effect. Because why that block effect comes? Why we want to have this block? Why we want to,
the homogeneity within the blocks.
homogeneity. Because why we come up with this homogeneity? Because there's a gradient. There may be some gradient. Any type of gradient, age gradient, nutrient gradient, maybe moisture gradient, any kind of gradient is there in a field or among the experimental area, so that we want to bring them into some kind of homogeneity units, so that we make them as a block. But you see here, I will take an example here. This is a river. This is my experimental unit. The box is my experimental unit. Tell me how the gradient, moisture gradient, this is water flow of a small canal. In which direction you could see the moisture gradient? Parallel to the water flow or perpendicular to the water flow, the moisture gradient. Think about it. I will get a glass of water. I'm asking moisture gradient. In which direction the moisture gradient would be? Right. Tell me in which direction you could see the gradient, moisture gradient. Here I'm talking about moisture
Perpendicular.
gradient. Yeah, perpendicular to the water flow. So that means there's a gradient in this direction. Do you agree with that?
Yes, sir. Left.
Right. So then you'll have to do the blocking. So I will block it perpendicular to the gradient. So perpendicular to the gradient means this is how you do the blocking. Right? This is how you do the blocking, for example, right? Am I right? Yes or no? Yes.
Yes, sir.
Yes.
Yeah, I need your response. It's free of charge, just to say yes or no. We don't hire anything from you to say whether it is yes or no. Right, fine. So this is the gradient. Look at here. Moisture gradient in this direction.
Yes, sir.
Right? Moisture gradient in this direction. So that we'll have to block. This is, let's say, block 1, block 2, block 3, block 4. 4 blocks are there. So number of blocks deciding, that depends on us. We can discuss that, how the treatment arrangement should be. But here, when you talk about this gradient, this gradient, what do you think about this gradient? There's a uniform gradient. So let's say here I am taking soil here, A, B, C, D. I am taking soil from these 4 places, A, B, C, D. Can you order according to the moisture gradient? Which one is higher to lower or lower to higher? Can you order which one?
High moisture content in A, then B, then C, then D.
You see, sorry, this is D. There's a uniformity in either increasing or decreasing. Right? Gradual increase or gradual decrease, either this direction or this direction. Right? So this is a normal procedure. If you have a gradual increase or gradual decrease in the moisture or any other cases, or gradual gradient is there, so this is called as the pattern of gradient. Pattern of gradient. Pattern of gradient means in this direction. There's a pattern of gradient decreasing of moisture, right? Under such situation, we can go for blocking. Under such situation, we can go for blocking. Suppose if you don't have any pattern as such, then we cannot do the blocking, right? I can take an example later on, along with introducing the subject. So here, in the Anova, now everybody should know what is Anova, right? Analysis of covariates. So Anova is done when there's a gradient. We know that there's a gradient. If there's a gradient with no pattern, then we will have a problem in the experiment. Then we go for the technique called as Anova. We have the gradient, but there's no pattern. If there is a gradient with pattern, we can go for RCBD, no problem, blocking. Blocking can not necessarily RCBD, even Latin square is a blocking, two-way blocking, this direction and this direction in Latin square, right? So in both cases, the gradient is uniform. There's a pattern in the gradient, but there are some occasions we come across with no pattern. All right. Under that circumstance, we can go for Anova analysis of covariance. Right. With that very basic introduction, we will go back to the theory. I will put this notes, analysis of covariance, the whole notes, I will put it on the LMS. Huh? You don't need to write this. But if I say anything additional, yes. Right. I will take some example in agriculture. All right. Before that, we understand the concept. This is what I said, directional variability. There's a pattern. There's a pattern, variability, moisture variability. If the moisture variability is in directional moisture variability, to increase the precision of the experiment, we go for blocking. As I pointed out, we go for blocking. But there are some occasions we say this variability, direction of variability is not clear. Under that circumstance, we can go for analysis of covariance. So you understand in which situation we'll have to go for analysis of covariance. That doesn't mean all the time we'll have to go for analysis of covariance. So depend on the situation, right? We will take the first example. Weedicide treatment applied to plots with variable amount of weeds. Now we have a problem. Look at this and write down this, and I'm going to go to the blackboard. Remember that word. Weedicide treatments are applied to plots with variable amount of weeds. Right? I'm going back to the blackboard. So my experiment here, weedicide. I'm going to apply weedicide. Tell me some weedicide, name of the weedicide. One type of weedicide. Broadleaf weedicide. Agronomy people, Nelum.
MCPA.
MCPA. Right. What else?
2,4-D.
2,4-D. 2,4-DP or 2,4-D? I couldn't remember now because I am not working with that. Okay. What else? Only two. You can tell some name, commercial name. These are generic name. No? These are chemical name. No? Tell me some commercial weedicide for broadleaves. Agriculture department in the million. What do you call it?
Glyphosate.
Huh? Glyphosate is total killer, isn't it? It is not specific for what do you call broadleaf. Hamokkama maraganwan. Specifically for broadleaves. Agriculture department people, how many people are there? Agriculture department. But I want to. Yeah, we will go for brands. Meco prop. Somebody said Meco prop. Huh? Meco, I will write prop. One. Dicamba. I don't know. These are new to me. Huh? M60. Tell me, these are broadleaf weedicide. Huh? I'm just considering only broadleaves because we cannot compare. For example, we cannot compare MCP versus glyphosate. No, MCP is broadleaf weedicide. Glyphosate is total weedicide. So that I cannot compare these two because definitely glyphosate kill more weeds than the MCPA because MCPA killing only one type of weeds. If you take number of weeds killed, glyphosate killing more. There මං compare කරනකොට ඔක්කොම එකම වර්ගය තමයි compare කරන්නේ. දැන් broadleaf weedicide නම් broadleaf weedicide විතරයි compare කරන්නේ. අපි glyphosate එක්ක compare කරා නම් ඒක සාධාරණ නෙමෙයි. ඒ glyphosate අනිවාර්යයෙන්ම ඔක්කොම මරනවනේ. நாங்கள் compare பண்ண එක broadleaf weedicide எடுத்து compare பண்ணா better. இப்ப broadleaf-க்குள்ள glyphosate கொண்டு வந்து போட்டோம்டா என்ன பிரச்சனை? glyphosate-ன்றது total weed killer எல்லாத்தையும் அழிக்குமில்ல. அப்ப கடைசியில நாங்க எக்ஸ்பெரிமெண்ட்ல வரைக்க glyphosate நல்லதுன்னு சொல்றதுல அர்த்தம் இல்லை. ஏன்னா அது அந்த வகையான weedicide total killer. So that for my experiment I'm taking weedicide which are let's say coming in the commercial level which is based on our broadleaf or killing or suppressing the growth of broadleaves weedicide. Tell me, விளங்கப்படுத்துறதுக்கு கண்ணெறிஞ்சல்தான்டா சொல்லுங்க பாப்போம். Example. Now I need example. Have you heard about? I never heard about Mecoprop dicamba. M60. Yes, I heard about it. Is there any other weedicide? Agriculture department in the order million.
Sobit, sir. Sobit.
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 Spelling right?
Okay, sir.
Yes.
Sobit, Tristar.
Tristar.
Oh.
I don't know, but okay, that is enough. So I will start. Sorry, I will go with these four types. I will go with these 4 types. So now writing down is difficult, so that I will write these names as renaming. W1, W2, W3, W4. So if I say W1, it is Mecoprop. W3 mean M60, W2 mean dicamba, then W4 mean Sobit, right? I'm going to use this naming. Now I'm going to explain an experiment. Now I have a field. What is the function of these weedicides? Subaraj, what is the function of this weedicide? Isn't the தொழிற்பாடு என்ன?
Hormones.
இல்ல நான் சும்மா சிம்பிளா கேக்குறேன். இது என்ன தொழிற்பாடு என்ன?
Weeds அழிக்குது.
weeds kill பண்றது. அதாவது weeds அழிக்கிறது. Right? So the function of these weedicides are killing what sort of weeds? Broadleaves. Killing broadleaves. Right. Now I have a 10 into 10 meter plot. Just a field. natural field where you get weeds, because naturally we'll have to allow the weeds to come, then only we can test these different weedicide, right? அதாவது இயற்கையாகவே நாங்கள் இந்த காணியில புல்லு முளைக்கிறதுக்கு விட்டுருக்கு. எங்களோட நோக்கம் வீடிசைடை பாவிச்சு புல்லுகளை அழிக்கிறது தானே, புல்லுகளோ அழிக்கிறது தானே. அப்ப வீடை கொண்டு போய் நாங்கள் நடையலாம், நட்டு போட்டு எக்ஸ்பெரிமெண்ட் செய்யலாம். இயற்கையாக வர வீடை எப்படி අලිකරන්නද தான் எங்களோட நோக்கம். අපේ අරමුණ මේ වීඩිසයිඩ් පාවිච්චි කළා ඉබේම එන වීඩ්ස් ටික කොහොමද අපිට කන්ට්‍රෝල් කරන්න පුළුවන් කියලා තමයි අපි මේ ස්ටඩි එකේ යන්නේ. අපිට හිතවල වීඩ්ස් ටික ගිල්ලා හිතවල වීඩිසයිඩ් ගන්න එක නෙමෙයි අපේ අරමුණ. සෝ ඉබේම එන වීඩ්ස් කොහොමද අපිට කන්ට්‍රෝල් කරන්න පුළුවන්. අපි වීඩ් කන්ට්‍රෝල් කියන්නේ හිතවල කන්ට්‍රෝල් කරනවා නෙමෙයිනේ. ෆීල්ඩ් එකේ කොහොමද වීඩ්ස් හැදෙන්නේ? අපි හිතවනවාද ගිල්ල වීඩ්ස් නෑනේ. ඉබේම එනේවනේ. ඒක කොහොමද කන්ට්‍රෝල් කරන්නේ? நாங்கள் ஃபீல்டில் வீட்ஸ் கொண்டு நடுறோம் இல்லையே, வீட்ஸ் தானா முளைக்கிற சாமான், அதை எப்படி கண்ட்ரோல் பண்றாண்டா தான் இப்ப எங்கட ஸ்டார்ட் விளங்கிச்சோம். நாங்கள் கொண்டு நட்டு ஸ்டடி பண்றதுல வேலை விளங்கிட்டா. இப்ப வீட் கண்ட்ரோல்ன்றது நாங்கள் நட்டு போட்டு அதை கண்ட்ரோல் பண்றோம் இல்லையே, இயற்கையா வாரத்தை கண்ட்ரோல் எப்படி கண்ட்ரோல் பண்றதுதான் ஸ்டடி. Now my question is, so we have a field, natural field, where you have a lot of weeds. Now we will concentrate only broadleaves, doesn't matter. But anyhow, I am going to talk in terms of weeds. So here I say some areas, let's say A, B, C, D, E, F, G, well ordered nicely. D, E, F, G, H, I. I have marked some area. Now if I count, let's say this is some plot. These are, let's say, I have put a circle. Anyhow, you can do it in circle also. This is a 2 into 2 meter plot. This is a 2 into 2 meter plot. This is a 2 into 2 meter plot. All are 2 into 2 meter plot, right? All are 2 into 2 meter plot. Now, my question is, which plot is having high amount of wheat, or which plot is having low amount of wheat? Can somebody answer this question? Subraj, சொல்லுங்க. I'm just talking about the concept. Tell me, in a field, is there I mean, chalo, yeah,
near the bun size area, AD.
Yeah. Near the bun side. Yeah. What is the reason near the bun side? A, B, C, yeah.
ADG.
ADG. Okay.
HI.
We say the four side are bun. All
Yeah.
four side are bun. This is you have bun here. All four side are bun. I will put it in red color. This is bun. This is bun, this is bun, this is bun. Now tell me, now we'll have to tell precisely which one is having high and which
Then
is having low.
which sites are having the water entering area?
Water, no, say no water channel here. Here, no water channel. There's no irrigation channel here. Channel irrigation channel. No irrigation channel here. I'm asking weeds, where the weeds is high. Because weeds are growing naturally, no? Right. Tell me, or it is a flat land. The land is flat. You said the bun side, the weed is high. So I agree. A, B, C, F, I, H, G, D are having relatively high weeds. Then we can argue that. Okay. But I want among this, which one is having the highest yield, highest weed? In the early case, we said no. Here I said, I asked a question, which one is having high moisture? Which one is having high moisture? So A is having high moisture. B is having next to A. C is having next to B. D is having next to C. Now, similarly, because here we can rank, we can say A, B, C, D is the order. Now tell me what is the order. Can we say the order here like A is having high, B, C, F, I. Can I say like that? Yes or no?
Can't, sir.
We can't say. Why?
Many factors affect that weed.
This is the problem. So here, you see, but can we say like this? The number of weeds in field A is equal to number of weeds in field B, number of weeds in field C, and so on. Can we say like that?
Can't, sir.
Can't say mean normally not. Can't say it vada. Can't say and padilaga. We can say actually not equal. If I count the broadleaves, for example, in this field, the number of broadleaves maybe in 2 into 2 meter plot, I have 25 broadleaves. Here I have 28. Here 42. Here 26. Here 45. Here 52. Some numbers I'm just saying. Here 35. Right? So likewise, is there any pattern here in this gradient? Because the number of weeds, because we are going to see how many weeds are killed by this weedicide, isn't it? So the initial level should be same to test. For example, if I say I'm testing here weedicide 1, in this plot weedicide 2, in this plot weedicide 3, in plot weedicide 4. To see the effect of weedicide, what do you think about the initial number of weeds in the field? It should be same or not same to evaluate the weedicide. Let's say I am having here 50 weeds, here I am having 55, here I am having 70, here I am having 75. Do you think this is a good experiment?
No, sir.
No. Why?
Means numbers are different from.
Yeah, because we are not giving equal opportunity to see whether which weed is performing better, right? Now you see, what about this now? If I do an experiment like this, what do you think? Is
Yes,
it good? Yeah.
yes.
Yes, this is a real equal chance to everybody to come up with which weed is better, because I'm giving 50 weeds for all the we decide. Maybe this we decide kill out of 50, it may kill only 38. This may kill 45. This may kill 49. This may kill 32. So we can say by visually, we decide 3 is better because it is relatively killing more weeds, right? Giving more opportunity, right? So having same opportunity, now we can compare. But in naturally, can we have this situation? Having all the plots with same number of weeds, will it possible?
No, sir.
Naturally, yes, no. So this is the situation where we apply the analysis of covariance. So there's no any directional variable or directional gradient, because there's a gradient. If there's no gradient, all the numbers will be same. All the numbers will be same if there's no gradient. But there's a gradient. From here to here, there's a gradient. Here to there, there's a gradient. Here to here, there's a gradient. But you see, the gradients are not uniform. So under that circumstance, we go for analysis of covariance, right? So this is just an introduction, right? So example, I explained with the V decide very well. So which is true for the second situation? What is that? In a field, fertility. If you take the land, 10 meter land, flat land, 10 meter land, I'm just concentrating the nitrogen. I am looking at N2. Nitrogen, right, in this area. Nitrogen in this. Nitrogen in this. Nitrogen in this. Nitrogen. It is a flat land, right? Let's say A, B, C, D, E, F. Can you tell which one has more nitrogen, which one has less nitrogen by visually? Can we say A is greater than B, greater than C? Can we say like this, nitrogen? Because it is a flat, yeah, we cannot say. It is a flat land. Now let's say I have a slope land, A, B, C. Can you tell me where the nitrogen level is high?
C higher.
Here there's a gradient. C is higher than B, than A. Now we have a logic. So here we can do RCBD, blocking. Here blocking is possible. Here blocking is not possible. You see? So under that circumstance, we'll have to do the analysis, we'll have to do the experiment, what to do. So under that circumstance, we go for analysis of covariance. Is it clear? Is it clear to everyone? In which occasion, yes, in which occasion we go for analysis of covariance. I didn't talk about the flesh of the Anova yet, but I'm introducing this design, in which occasion we go for this design, right? So another example you can read. Sometimes variability occurs after establishment of experiment. So you see, this is that is the establishment of experiment, right? What is that? pest attack on plants. For example, that is another case, pest attack, because sometimes after establishing the field, maybe another treatment we can think about it, another treatment or kind of problem, right? Now let's say I have started with this in RCBD or whatever it is, right? Now we have, this is block 1, block 2, block 3, block 4, treatment 1, treatment 2, treatment 3, treatment 4. 4 treatments are there as an example. Now what is the problem is, all are, let's say, maize variety, maize, right? Maize with, let's say, 4 fertilizer treatment, T1, T2, T3, and T4. Maize variety. Now, what is happening? Suddenly, overnight, can you remember very recently some damage made by some people to maize? What is that? Now it is less. Yeah, now it is less. How do you call?
Fall armyworm.
Fall armyworm. I'll put it as FAW, fall armyworm. Right, now they come to the field and attack. Do you think the group of fall armyworm comes, they speak among themselves and say, they discuss among themselves and they divide among themselves. I'm going to this field, 5 armyworm. I'm coming to this field, another 5 coming to that field, right? Another coming to that field. Do you think are they talking among themselves and coming to the field in equal amount? Yes or no? அவைகளுக்குள்ள காய்ச்சி போட்டு ஆமி ஓமுக்குள்ள காய்ச்சி போட்டு நாங்கள் அஞ்சா பிரிஞ்சு போவோம் ஒரு ஃபீல்டுக்கு மண்டு வருவீனியா அல்லது?
No sir, they randomly attack.
So ඒගොල්ලෝ කතා වෙලා නෙමෙයි එන්නේ නේ. ආමි ඕම් ටික කතා වෙලා නෙමෙයි එන්නේ. මං මේ ප්ලොට් එකට යනවා ඔයා මේ ප්ලොට් එකට යන්න. එහෙම දෙන්නේ නෑනේ. So they attack. On because we cannot predict the attack pattern, because this is after starting the experiment. This is not before the experiment. This is now we are running the experiment. Let's say after 2 months, we have done the RCPD, this treatment. Now armyworms have come. Now they are attacking. So maybe in this, maybe the plant density is same. We say plant density is same in each part. Here maybe 100 armyworm attack. Here maybe 200 attack. Here maybe only 50 is there. Here maybe 75 armyworms. Here maybe 100 armyworms. Here, right? So there's no pattern. Randomly, the numbers are random. We don't know. Now, how to, because what is the problem with the armyworm? Because what is our ultimate aim of this experiment? Ridi nokam enna angada ape antima goal එක මොනවාද මේකේ?
Find the fertilizer effect on maize growth.
Find the fertilizer effect on
Maize yield.
maize yield. Our final objective is yield. So what is the problem here? The armyworms attack. So depend on the number of armyworms, yield will increase or decrease. I mean, yield will change. So you see here, if you compare this plot and this plot, for example, What do you think about these two plots? Definitely, the plot with high armyworm will have more chance to go with low yield or yield reduction compared to the armyworm with 75, as an example. So this is a problem, because initially we didn't think about it. Now we have how to incorporate that information into the experiment. Because how the yield reduction can be proportionate to all these treatments. So this is a new experience for us, so that here we cannot completely ignore the number of armyworms attack the plants. So here we'll have to consider the number of armyworms that is attacking the field, at least number of armyworms or number of plants affected, etc., etc. So that has to be accounted for the analysis, because it will impact on the final yield. Is it clear? So you see, now after starting this RCBD, suddenly problem. Now we can talk about Anova in this situation as well. Earlier situation and this situation. Earlier situation, before we starting the experiment. Now, after starting the experiment, that problem is there. How to look at the Anova. Is it clear to everyone? The examples?
Yes, sir.
Yeah, right. So this is some of the examples. 3 examples I gave. You can think about any other examples in the field of agriculture. Right, a procedure for comparing. So I'm talking about the text. A procedure, it is a procedure for comparing treatment means, because it is the comparison of treatment means. So you haven't learned the theory of the comparison of treatment means. Actually, you compare the treatment means that incorporates, that include the information of about another variable, that is a quantitative variable x. Right? We have already talked about that in this last example. So we can consider as another variable, x variable, for example. All right? Number of pest or pesto armyworm in the plot. So this is, as we said, 75, 50 for each. I mean, for every plot, you'll have to calculate, count the number by doing sampling or whatever it is. You'll have to count that up. So this is what we call as a new variable I am introducing for this experiment. So this is a quantitative variable. Number of pests in the plot. In earlier case, what is the quantitative variable here? I can include. In this case,
Fees.
yeah, number of feeds. In the fertilizer case, we can include amount of nitrogen, initial amount of nitrogen on the soil. Right? In earlier I explained the nitrogen variation. So we do a nitrogen analysis for each places. Then we find this much of milligram there, this much of milligram. So that information is additional information. So initial number of weeds, initial amount of nitrogen, the number of pests that has been damaging the crop. Likewise, we can talk about it. Right? So that is a quantitative variable. Right? So that is, can you all see this? I have taken something else, I think. Can you see the slide?
Yes, sir.
Okay. So this is a quantitative variable, which is an x variable. So this x variable right? Is a quantitative variable. It is called as covariate. This X variable is called as covariate. So in our 3 examples that we have taken, initial number of weeds in the field before applying the weedicide, that is called as covariate. So initial number of weeds is a covariate in our first example. In second example, the nitrogen, amount of nitrogen. So initial level of nitrogen in the soil is also called as covariate in the second example. The third example, the number of pest attack in the field is called as covariate. So this is called as covariate. So hereafter, if I refer covariate, you should know what is this covariate. Right? My explanation on this is mostly on animal science experiment. So everybody will understand later on. So most probably we will continue this. So the procedure of Anova is a combination of Anova with regression. So this is the most important part in the Anova. Anova means it is the combination of, you have already learned, combination of 2 aspects. One is regression. You can recall the regression. You learn tomorrow regression and come to tomorrow with some knowledge. I will ask, right? You study the regression and come back. Yesterday also I talked about regression and Anova. So this Anova is the combination of regression and Anova. So hereafter it is a combination of, so you should know hereafter it is a combination of regression and Anova. It's not only Anova, it's something, Anova plus something. So it is a regression and Anova. Right, I will see whether yes, we have some more minutes. Do you have any other classes today?
No.
Right. No. Okay. Right. We will look at this slide. Then we will go tomorrow to the other slide. Right. So now, what are the conditions for covariates? Covariates. Now everybody should know what is this covariates. It is the variable X variable. We have already taken. Right. So this is something related to the regression also. Can you remember? X variable, Y variable in regression. So this is going to be taken as a X variable. What is the X variable? Somebody yesterday said independent variable. Can you remember? Yes. So study about regression, we will discuss further. Right. Normally, covariate coming in a ratio scale. So measure of scale, measurement, scale of measurement. But this is not necessary or compulsory. Sometimes it comes as the count data also, but it is a quantitative data. Definitely it is a quantitative data. The covariate is a quantitative data. The second point is this covariate is assumed that it has a linear relationship with the response variable. That means, so here in the first example, we said weeds, number of weeds, right? Number of weeds. They have highly linear relationship with the response variable. What is the response variable in the first example? Number of weeds killed. Because after applying number of initial weed, number of initial weed is the X variable. The response variable is ultimately after spraying the weedicide, we count how many weeds dead, is it? In the second example, or third example I will take, number of fall armyworm in the plot, number of fall armyworm. It is the yield. Right? It is the yield of the plot, maize yield. What do you think normally? When the armyworm number increases in a plot, what will happen to the yield? Increasing or decreasing?
Decreasing the yield.
Right. Decreasing the yield. Right? Decreasing the yield. So it is a negative linear relationship, not positive, negative. When the armyworm increases, the yield is decreases. When the armyworm decreases, the yield is increases. So it has a negative relation, but it has a linear relation. That is one of the assumptions that we do. The third one, you can read. Third one, covariate should not be affected by the treatment itself. That is more important. So that is why we are taking the initial number of weeds. Covariate, whatever the treatment, should not be affected by the treatment itself. Sorry. Covariate should not be affected by the treatment. Whatever the treatment that we are applying should not affect the covariate. If you take the initial reading, it will not be a problem, right? Then it should be measurable without error. So those are few normal points that we discuss in other cases as well, right? Whatever we measure as the covariate should not be biased. We need to get the actual information. Next one, the regression lines for the different treatments are parallel. That we will talk about later. What do you mean by that? The responses are parallel for each treatment that we will see tomorrow. And some good covariates in the experiments are in different fields. Initial body weight of the animal, right? Initial body weight of the animal. Why? Now you see, let's say Tanush Kumar. I don't know how Tanush Kumar looks like. I don't know Tanush Kumar. And I take your batch rep, Rania, because everybody will understand if I say like this. I don't know what is the body weight of them, Tanush Kumar and Rania. Now, do you think if Tanush Kumar has a headache, both are having headache. If both are having headache, if Rania takes 2 Panadol, let's say I will take 2 Panadol. If Rania takes 1, Rania, are you there?
Yes, sir.
Panadol. I don't know how many Panadol you take. Panadol. If Rania takes 1 Panadol, she gets cured from the headache. But Tanush Kumar, when he takes 1 Panadol, it doesn't answer. He needs to take 2 Panadol. Can you explain this phenomenon in simple terms? Because this is depend on our metabolisms. Metabolisms are, even though we are doing with the same concept or same cyclic metabolism, but the rate of the metabolisms are different from person to person. This is true with the plants. This is true with the animals. Everything is applied to all organisms. So metabolisms are different from person to person. Okay, that is the nature. That is the nature of the beauty of the nature, right? So let's say when you, for example, when you apply the treatment to animals, for example, so some animals are with high weight. Let's say yesterday we talked about in the example milk yield before and after. So when I take the number of animals, let's say 5 animals or 8 animals for the experiment, we cannot get all the animals in the same condition. The animals are in different condition. So one typical different condition is weight. So their weight is different. I cannot take same weight and 2 animals. Impossible in a small group. I mean, if you take within Sri Lanka, yes, but when you try to do the experiment, yes, not possible. So initial weight of the animal can be considered as a covariate. Then second thing is age of the animals. That is also a problem. We cannot get the same age animals for the experiment. Maybe at least by months it may differ. Some 2 years and 3 months. One animal, another animal 2 years or 4 months. Still in months they are different. If it is differ in months, still differ in all the aspects. Maybe weight differs, metabolism differs, everything is differs, right? So that age of the animals and plants. Then another example, milking before the treatment. Yesterday we talked about milking. I have the same age, same, let's say same age, same parity, same breed. I can take all these constant, but still the milk yield from animal to animal varies. So before giving the hormone, I can take the initial milk yield as the covariate. Later we will see how to adjust these values. So that is a good information. Diameter of the plant, diameter or the girth of the plant. That is also one example that we can take for the covariate. You see, different examples are there. Initial level of any variables on serum. If you take, let's say, 2 people with the same age, same weight, everything is same, right? But their serum levels are different. The serum level, you know, blood count, white blood cells, red blood cells, the amount of oxygen in the cells, those are different, you see. So before giving any treatment, we can take all these information as the covariate, you see, right? So that is how we can get the information. So this is initial information that we take it or collect it from the experiments. Even we could collect the information after or during the experiments, also possible. So then we can consider those. I have already given one test attack. So that also can be considered as a covariate. All right. Right. So these are some of the examples in covariate that could be considered for our experiments. So this is most biased towards animals, some of the example, but we can take it the field also, like nitrogen level or fertility level in the field. Fertility level in the field is not same, different. Or amount of organic matter in the flat land. Here they are everywhere different. In the topsoil, everywhere different. But we mostly assume that almost all the area is with more or less same amount of fertility. That is how we take the assumption and do the experiment. But if you are really concerned, then you have to evaluate. Right. With that remarks, I think I can complete today.